and welcome to Season 2 of So Now What with Gates Cambridge, a podcast tackling some of the world's wicked problems with those dedicated to doing something about them. I'm Catherine Galloway, and my guests, as always, are Gates Cambridge scholars working to make an impact in the lives of others. And what could be more impactful than discovering that we are not the only ones out here, after all? Space is heating up again for us humans, with NASA's Artemis missions poised to put crews on the moon for the first time since the Apollo landings of the 1970s, and private commercial interests from America, China, Japan, India and Europe outspending governments to stake their claim on space tourism, space mining and space comms. Power, politics and profit aside, there's also a fresh dose of awe on offer. The first exoplanet beyond our own solar system was only discovered in 1992. Now we've counted more than 5,000 of them, some of which may be more like our own pale blue dot than we expected. So what does astronomy tell us about our place in the universe? And what on earth are we meant to do about it? My guests this month were all starstruck from a very young age, came into each other's orbits at Cambridge and are now all based in the United States. So a very warm welcome to the Zoom studio, Luis Welbanks, Gates Cambridge class of 2017, speaking to us from Arizona, Rebecca Charbonneau, Gates Cambridge class of 2018, speaking to us from Washington, DC, and Yinuo Han, Gates Cambridge class of 2020, joining us from Pasadena, California. Thank you all very much for being here with me today.
Thank you so much.
Thank you for having us.
Now, Luis, your fascination with exoplanets means you're part of a huge wave of discovery in astronomy right now, one that puts us, in your words, as close as we have ever been to finding out if there is life on other planets and whether we are alone or not. In February 2023, your interpretation of images sent back from the James Webb Space Telescope landed you on the front cover of Nature with a piece titled Brave New Worlds. And you're soon to begin a new role as assistant professor at the School of Earth and Space Exploration at Arizona State University, where you'll continue to argue that observing and measuring something up there tells us fundamental things about who we are right here. Rebecca, you're a historian of science who had your first lightning bolt moment when you saw Galileo's telescope during a research trip to Florence. But since then, you've focused your attention on how the search for extraterrestrial intelligence, or SETI, has shaped communication and cooperation on Earth. You were the first ever social scientist to receive a Jansky Fellowship at the National Radio Astronomy Observatory, and that interest in the relationship between science and power fed into your book, Mixed Signals, Alien Communication Across the Iron Curtain, which came out in October. You're currently based at the American Institute of Physics, and you only occasionally check your reviews on Amazon, which, entirely appropriately, are all 5 stars. And, your current research at the Division of Geological and Planetary Sciences at Caltech has you examining things that are variously described as stellar fireworks and the exotic peacocks of the stellar world. What you're actually looking at is an extremely rare type of star known as a Wolf-Rayet, stunningly beautiful, potentially dangerous, and 8,000 light years from Earth. You find that kind of distance both comforting and awe-inspiring, you say, putting our solar system into perspective, whilst also helping to understand why and how we came to be. Now, of course, the galaxy is huge. We are tiny, the stakes are massive, and we only have a short time together. So I'm now going to make a solemn promise to stop with all the space puns and instead ask you to share the one thing you're bringing to the table today that will help us understand what we're really looking at. Luis, let's start with you.
I'm bringing to the table hope. I actually was thinking about it on the walk here, and I was like, this morning I'm feeling hopeful about the state of the world. It's a very kind of controversial thing to say, but I really was thinking that in terms of our astronomical perspective and where we can go from now, it can only go upwards. If we work together on this, and as we have demonstrated year after year after year, when we work on something and we put our vision up there, we ultimately end up succeeding. So I'm hopeful for what we can achieve together.
And space, of course, is the ultimate collaborative, isn't it? We either get there together or we don't get there at all. Rebecca, what about you? What are you bringing to the table?
Yeah, I'm so inspired by Louise's sense of hope, and I'm hoping to get there myself. But I think, unfortunately, today I'm bringing to the table a deep concern about the state of science in the United States. I'm speaking to you today from just outside of Washington, D.C., where I've witnessed firsthand the challenges posed by recent censorships, firings, and significant budget cuts to key scientific agencies like the National Science Foundation, NASA, and others. So, today, as we're going to dive into discussions about astronomy and worlds and life beyond Earth, yeah, I'm really thinking about how important it is to preserve and protect the institutions and the scientists who will make these discoveries possible at all.
Thank you. My goodness, there's very much the yin and yang going on there. We've got hope, we've got fear, a little bit of trepidation. That is space in a nutshell, really, isn't it? What are you bringing?
I think I might strike a more optimistic tone and say I bring a sense of excitement from the perspective that I think a lot of astronomy is about finding out things that you didn't know. And I think there's so much that we've learned about distant alien solar systems, and also, as you were saying, Wolf-Rayet stars that are sort of thousands or even more than that light years away. And the fact that we can learn anything about those is I think, really exciting. And I think there's so much more that we will learn in the coming years. And that, for me, is very exciting.
Luis, and you're in very, very new fields, and you're really at the start of your careers. So that must be incredibly exciting, sort of growing up with these new images from the James Webb Telescope and so on. You're literally seeing things that no other astronomer before you has seen before. What does that feel like?
It's a combination of every single feeling ever felt. The excitement, the fear, the doubt, the anxiety, and then you just shake them all up, and then it's kind of like an 8-ball, see which one shows up first. I remember seeing for the first time a planetary spectrum from the James Webb Space Telescope, and just being in a group of, I don't know, there was 10 of us that saw it for the first time, and then we saw things that we were expecting, but then seeing the first bump, the first wiggle, that we had no idea what it was. And that sense of excitement that is talking about, that sense of, holy moly, what did we miss? Where is this going to take us? Let's now race and let's actually have fun. This is why this telescope was built. That sense of confronting your expectations and confronting your fears and feeling inspired to go to the next stage, that is what is really motivating me to keep in the field, and I want to bring to the table and share with others.
Is it the same for you, when you're looking at these images that are thousands of light years away?
Well, actually, a lot of the time when I open the data from, say, Webb, I have no idea if I'm looking at the right thing. Is there anything there at all? I'm looking at an empty patch of sky, and have I put in the right coordinates of where my star is? And the moment you see, there's something bright in the middle, and that's good. And you sort of rescale the image and go, actually, there's a lot of stuff there, and you see all these random things that you didn't expect to see. And you go, that doesn't make any sense. But hang on, I think it does make some sense. You do go through a lot of sort of emotional variation in the first few seconds, even after looking at the data. So yeah,
I love how you describe that as an emotional variation. That's such a scientific term. That's so wonderful.
Yeah.
A variation. Luis, how old were you in 1992 when the first exoplanet was discovered?
Yeah, it must have been a year old.
And now, in your lifetime, we've mapped more than 5,000 of these things that you're spending your life studying. My first question to you really is, if the science is not only this new but going this quickly, how confident do you feel that in your own lifetime, by the end of your career, you'll be able to say there is actually some kind of life somewhere else on Earth?
Isn't that the question, right? How confident do I feel that we'll get that answered by the end of my lifetime? I'm going to give it 1 in 5 odds. I think that when I say that we're closer than ever, I truly mean that. I think we have the best odds that humanity has ever had. But we have, for me to be 100% sure if that ever exists, we need to agree on so many things. What do we mean by life, and what passes the threshold for sufficient evidence, I always think of my grandmother back home, like what sort of evidence would convince her that there is definitely life out there. And I think for her, anything short from a handshake from a little green person is not sufficient evidence. So I think by the time I die, we will have claims of a gas, of a combination of molecules that suggest that something is out of equilibrium that could be compatible with life forms as we think they work. And then there's so many qualifiers in that statement that is why I give it the 1 in 5.
This will be otherwise known as the Mexican granny test, I think, from now on. Which you will all write.
The MGT, I like it.
Now, Luis, I know we nearly lost you to history because you were very torn. You wanted to do, astronomy and history together. Rebecca, you actually are a historian and believe with Luis that we have to think of the two in combination. And when we were speaking before recording this podcast, you said to me, it's so important to think about timelines. So given that we seem to be rushing headlong into another space race era, and this one that's being driven as much by commercial as well as national interests, what does your own research suggest that we could learn from a previous space race era, and awareness of how that could help us navigate now?
Yeah, so one of the things that struck me at the start of this podcast is Luis and Yinuo's optimism and positivity, despite the circumstances we're in, which are rather quite dire for science, at least in the United States, which of course will have a ripple effect across the world. And I find that both lovely and also with historical precedents, which is to say that even in the Cold War era, where there was so much conflict, so many barriers to science and scientific cooperation, there was a sense of optimism amongst scientists practicing during that time. My own research focuses on the search for extraterrestrial intelligence, which developed in the 1960s and 1970s, primarily in the United States and the Soviet Union. And one of the things that makes that field so fun to study as a historian is that it was really imbued with this sense of internationalism. Scientists who were thinking about the big picture questions, like, are we alone in the universe? Or what does it mean to be not just a Soviet or an American, but an Earthling? It really fostered that sense of global community and prompted them to want to work with one another across the Iron Curtain, even in the face of, again, tremendous hurdles. So again, when I see the optimism here amongst these two astronomers studying worlds beyond ours, it reminds me that this is consistent across the historical record, that there is an inherent optimism to asking these questions.
And do you think that in the same way, scientists essentially just sort of shot themselves over the Iron Curtain, really, back in Soviet times, and just collaborated somewhere beyond Earth? Can you see that happening this time around? The money and the power at stake are huge.
Yeah, so historians famously are so uncomfortable projecting into the future. So I can't say, of course, with confidence what I think will happen, but I can say, again, looking at the historical precedent, scientists are very good at getting around politics or using politics to their advantage in accomplishing science. And I don't see any reason to believe that wouldn't be the case today and moving forward.
Do you find yourself ever having to justify why this deep space work, this very expensive space work, is necessary? We're talking about scientific cuts, we're talking about all sorts of slashing and burning going on down here on Earth in terms of budgets. How do you explain to people what understanding these exotic peacocks in space could mean for us?
Yeah, I think in a sense it's a bit like painters painting things or poets writing poems and so on. It is a bit of a luxury in a sense, in societies that can pursue that. But at the same time, I think, despite all the other problems that we have to solve, ultimately, I think we are very curious creatures and we want to know our relation with the world in which we exist. And the physical world on the larger scale is, I think, what we study in astronomy, like where we come from, how planets form and how planetary systems form has very important implications on understanding the origins of life, for example. And those are things that I think we universally do care about.
Can you just describe in a nutshell for me, what you're studying exactly, what you're hoping to find?
Yeah, so there's sort of a few different things I work on. On the more planetary side, I'm most interested in sort of studying these really distant belts of comets and asteroids and planetesimals in other solar systems. And so we know that in our solar system, there are planets and there are these comets and asteroids that form belts. But we can also see similar belts in these other planetary systems. And their distribution tells you something about how these systems formed and how they evolved into the future. For example, the shape of some of these belts might have gaps in them. And these multi-ring structures could tell you, for example, there are planets sitting in there that could have migrated, so moved in their orbit by some amount at what period of time. And that could tell you something about how our solar system planets could have moved in the past by analogy, for example. And also, I think it's important to understand these things because where does water on the Earth come from, for example? It's not obvious that you can have water form on the Earth where Earth it currently is during the early sort of formation of the solar system. Perhaps this water was delivered further out from, say, asteroid belts or even cometary belts in the solar system. Now, why would these material come crashing inwards towards Earth? Does something have to perturb it, for example? Do we see evidence of this in other systems? Right. And how did the moon form? Perhaps via giant impact. That the moon might have important implications on tides on the Earth, for example. Tidal pools might be important for forming life, right? And do other terrestrial planets also have moons? Do they have the necessary conditions for giant impacts to happen and therefore form their moons, therefore for them to have tides, similar to what may have happened on Earth? So I think these questions are very sort of fundamental for us to understand where we come from. And a lot of our clues, I think, come from the study of extrasolar systems. And sort of the other thing that we talked about that I study is these Wolf-Rayet stars. Now, these are really rare systems. They're sort of the opposite of the solar system. They're the sort of extremely massive stars that are sort of dozens of times the mass of the sun. And they're at the end of their evolution as a star, and they're about to sort of explode and essentially become a black hole. And during that very final phase, a lot of that material is released to its surroundings via the form of dust. And that dust has really beautiful structures. You can use that really large-scale structures that you can image, these beautiful spirals that you described as stellar peacocks. You can link it back to the physics of how this dust is produced. And a lot of that dust presumably goes on to fill up the sort of volume in space. And some of it might go on to form stars and planets, like the ones that we live nearby. So I think, this flow of material really, I think, links together there's different processes happening in the universe.
Luis, when you were speaking to me earlier, you said, astronomers are just going to be the ones collecting the light, which I think, plays down your part as scientists a little bit. But astronomy, our very idea of space, as Rebecca's work shows, is not timeless. It is affected by where we're looking from and when we're looking, and also some assumptions about what we're looking to find as well. So do you see astronomy in some way as having that social role in playing a part, not just looking at the light, but also kind of shaping our discourse here on Earth a little bit?
Absolutely. I think that by the merit of it being a human endeavor, it is affected by all the things that we humans do. Astronomers, like everyone else, are still humans, and we go through the same emotions and the same challenges as any other field. We, despite our best intentions to be data-driven, unbiased, evidence-based decision makers, we have our own biases. We suffer from the same issues that affect our communities, our society, and our world. And as such, our interpretation of our observations, our interpretation of our role in society and in our communities will be affected by all these contexts. And while to the best of my knowledge, every single human ever at some point or another looked up the sky. The reason why we looked up the sky may be different. We were talking about, or you mentioned the discovery of 1992, but to some, really the discovery of the exoplanet is until 1995, when it was found around a sun-like star. The 1992 discovery sometimes is not really put into that context. But then also in the 80s, there were other searches that, while it was not claimed at that point, there were signatures of exoplanets already earlier. So it is also a little bit of our social narrative. Why was it that the discovery of an exoplanet was fully embraced in the 90s? And why was it that we were allowed, as a society and as a community of scientists, to think about changing the status quo of what planets look like, how planets are? The fact that at some point we were looking for planetary systems that matched the same structure that we have in the sun, in the solar system. Small planets inside, big planets outside. And that's what we were looking for. But when someone comes up and says, hey, actually, big planets can be very close in, can be very, very close in, much closer than Mercury is in the solar system, everyone's like, that doesn't make sense. That changes the way that we think about things. And that there was resistance. But that in a way also reflects the position of society that, okay, it is okay to change the status quo. It is okay to change how we define the boundaries of our knowledge. And we see that in the 90s, several changes happen in our communities. Some aspects of the postmodern life were embraced. There's no big narrative. It is okay to change how we believe in our institutions. We are going to be now in a globalized world. So all these things affect how we interpret our science. And from that perspective, things are going to keep changing. And I'm excited about how my environment is going to affect the way that we think about science.
Rebecca, I saw you furiously nodding there as Luis was talking. What would you like to add to his point there?
Yeah, Luis, I'm sad that you live in Arizona. I want to hang out with you more. I think everything you're saying is absolutely brilliant. I've been working on an exoplanetary history project at the American Institute of Physics, actually, and so I'm becoming quite familiar with that history. And I'm really happy that you raised that one. The 1995 discovery is often more credited than the 1992 discovery, but I think that you're raising a really critical point about the role of narratives and the narratives we tell about science and the role they play in astronomy. I think about this all the time in my line of work. To your point earlier about the MGT, the Mexican grandma test for detecting extraterrestrial life, I think that your grandmother must be a real skeptic, because actually in my work in SETI, we've found that actually the majority of Americans think that we have already detected life on other worlds. It's actually considered to have already happened. So there's a big disconnect between the public narratives and what scientists believe that we are doing. And that's another facet of astronomy that's really integral to a lot of the work that we do, which is because, like you said, Louise, we're like collectors, there is a need to justify to the public why should astronomy be something that the public invests in through taxpayer dollars. And it's, I think, in part the romantic and poetic aspects of astronomy that was referring to earlier that really do inspire the public, and it's something that the scientific community has recognized for a long time. Like even when NASA was established in 1958, one of the first things they did was they established a history office that was there to start writing stories about what the scientists were doing, what the engineers were doing. And that was hugely successful for NASA's reputation and its ability to continue to garner funding over the decades. When I went to Moscow many years ago to do my field work for my book, I went to the Russian Museum of Cosmonautics, and I remember being really tickled by seeing all the people in the museum. Many of them were wearing the NASA meatball on their sweatshirts, and I just thought it was so funny. Like, here I was in Russia, and NASA clearly was still really capturing the public imagination. And like Luis said, so that is really, I think, an integral part of science that doesn't get discussed quite as often as perhaps it should.
I'm going to do something that I've never done in a podcast before, which is share a question from one of my sons. And I said, "Oh, Oscar, we're going to do something about space." And he said, "Oh, I want to know if they think in the future there could be space wars." And I thought that was a really interesting question from a 10-year-old, because I think he's picking up on the fact that there are these commercial interests that are all jostling for control of something that we don't even yet understand. But everybody's absolutely certain that they're going to be drilling in space and they're going to be capturing this or that for whichever national interests. And I thought that was quite sad in a way, from a child who wasn't just able to be awestruck as you were as children about the what's up there. He was immediately thinking of territorial, conflict.
Well, I would argue there already are space wars, and I think you could argue in some sense that there really has been almost since the beginning of when we first became involved in space. It's not as exciting as Star Wars, perhaps, but there have long been like anti-satellite weapons. Different countries try to spoof one another's satellites or communication technologies, and certainly we have to remember that our first venture ever into space, like the first human-made object that ever went into space, was a German V2 rocket. It's part of World War II, and then shortly thereafter, of course, there was the Cold War. There, just as much as we were putting objects of exploration into space, we were putting tools that we could use to spy on one another. So space, while it has always been a point of optimism and exploration and science, has often equally served as a militarized space as well.
I was thinking of Rebecca talking about the fact that she saw so many NASA t-shirts, right? Like, NASA has been fantastic at being the PR branch of the US Army, right? And that is good. I mean, I'm being funded by NASA and I'm thankful for NASA, and NASA inspired me in so many ways. And that also shapes who the good guys are going to be, who the bad guys are. And for that is also part of what determines if there is a war. And the great thing about all of this is that every single community is going to have their own narrative. Just like myself and Yinuo and Rebecca are exploring the same topic from different perspectives, at different countries it's going to be different.
Luis, as you were talking there, I was reminded of Jimmy Carter's address, or his letter to extraterrestrials, which he attached to the Voyager spacecraft in 1977. Of course, you know it. That letter has been traveling now for 48 years out into this huge unknowable future that Voyager is traveling. And in his words, he said, This is a present from a small, distant world, a token of our sounds, our science, our images, our music, our thoughts, and our feelings. We're attempting to survive our time so we may live into yours. We hope someday, having solved the problems we face, to join a community of galactic civilizations. This record represents our hope and our determination and our goodwill in a vast and awesome universe. I'm just reading those words and thinking, can I imagine today's president writing something that hopeful or that far-seeing? It's really interesting to think about how the politics shifts what we see in the far distance. I asked Luis what he hoped to see by the end of his career, and you're the very newest in the new field that we're talking about amongst the three of you. What would you like to see? What would count as a success for you by the end of your studies, do you think?
I think for me, science is often very incremental. The kind of examples that we know very clearly from textbooks and sort of our sort of learning of science through school is based on lots of very famous names, and they have discovered people like Isaac Newton, who made very fundamental influences that we celebrate these days. A lot of those achievements were, as he sort of reportedly said himself, based on other people's work as well. So very often these sort of other people's work is also very incremental, and that's how I see most of the work that we do as scientists. And so I think it's very hard to say exactly what you will discover and what kind of discoveries are worthwhile. You might not even know in your lifetime what kind of impact you have made, as many is the case for many scientists in throughout history. So I think as long as sort of I'm enjoying the process, the public is sort of, the interest is captured by the job that we what we're doing, I would say that's quite a good thing.
We're getting near to the end, unfortunately, of our allotted space time on this podcast. I'd like you to sort of bring us back down to solid ground and give us something that we can all help you with, take with us. So could you possibly give us a so now what, Rebecca?
Yeah. So I haven't lost my concern over the course of the last 30, 40 minutes or so, but I think that in discussing the impact of narratives and engaging with our community and the optimism that has been expressed by my fellow podcasters, I'm feeling a real sense of responsibility, especially as a historian of science. One of my jobs is to chart, science as it happens. It's important to chart government involvement in science and to keep track of things that might otherwise be suppressed or censored. And so I feel, again, a real sense of responsibility to promote and support science through my role as a historian in this time period where maybe the historical record starts disappearing in some places, or science, for whatever reason, starts losing support. I feel, again, still concerned, but maybe a little bit of hope that my job in some small way can help contribute to promoting science.
So some of Luis's optimism has transferred over the Zoomosphere to...
I'm an optimistic person. It's just hard in Washington D.C. right now to maintain that unwavering optimism. But I've been inspired.
Thank you.
Gotcha.
What about you? What would you like to leave us with?
I would just encourage you to continue to be interested in science and astronomy. And I think for me personally, it's been quite a rewarding sort of journey to study astronomy. And a lot of my earliest interests came from just people around me talking about sort of the universe and so on. So I think, if you're interested, just keep following the news and talk about it.
Did either of you grow up with Carl Sagan's Cosmos series? I always think that's an excellent one to recommend to people. Maybe it's a bit dated now, but that's what I watched as a kid.
It's a gateway.
It's a gateway.
What about you, Luis? What's your so now what for us?
Well, on a personal level, I'm taking new friends. Rebecca mentioned earlier, it's so sad that you're all the way in Arizona. Let's set up something. Let's chat. I mean, we're still in the same country. Same thing, like California is right around the corner. The what now, I want to think about the following. We, as a scientific community, there's a bunch of us that are looking at planets light years away, 40 light years away or more. They're tiny. We're looking at the signature of what's going on in their atmospheres. And we're able to measure these gases and understand more about these planets than we know of our own solar system. We're able to really extract so much information of these very, 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 very far away planets to a greater level of detail than when we send probes to Jupiter and when we send probes to any other part of the solar system. I think if we can do that, if we can really reach out that far, I think we can also deserve to give ourselves the opportunity to reach out to our neighbors, to reach out to our colleagues, and really understand what's going on that side, to really understand their perspectives, and to really give ourselves the chance to collect that information and build new knowledge together. And that is where I'm taking that sense of hope, that no matter the conditions have maybe dire in a country right now, but they were dire in a country in the past. And as humanity, we still prevailed. And thinking about the big picture and thinking about how we can build these bridges, just like we build interplanetary bridges of knowledge, that is what gives me hope. And I want to think of the what now is just reach out. Look out for that new information and challenge the way that you think about the world and the universe.
Thank you, Luis. Well, I never give a so now what, but I'm going to give you all one, which is this beautiful book called Begin Again. And it's how I began my research for this podcast. It's a children's picture book written and illustrated by Oliver Jeffers, but in a very beautiful way, he writes, "When you look from far enough, it is clear we all come from Earth. So there's only us." And that to me is just a really beautiful encapsulation of what we've all been working towards today in this episode. So huge thanks to all of you, our two astronomers, Luis Welbanks, the incoming assistant professor at the School of Earth and Space Exploration at Arizona State University, and Yinuo Han, currently a postdoctoral research associate in planetary science at Caltech, as well as space historian Rebecca Charbonneau, based at the American Institute of Physics in Maryland, and recent proud author of Mixed Signals, Alien Communication Across the Iron Curtain. We've packed a mind-bending amount of big stuff into this tiny blink of cosmic time together today, and I wish all three of you the very best of luck as you continue to boldly go across spaces and places that the rest of us can only imagine. My thanks too to producers Mandy Garner from Gates Cambridge and Nick Saffel from the Central Communications Office at the University of Cambridge. And of course, thanks to all of you for listening and for sharing your thoughts and ideas with us in the comments. I'm Catherine Galloway, and this is So Now What with Gates Cambridge. Join us again next time for another wicked problem dissected by those determined to do something about it. Thank you.